Hi there, what's up, amazing people, students, lovers of chemistry out there? I'm super excited to be here with you on today's episode of Question for the Day. And on today's episode of Question for Today, we are calculating the enthalpy change for a chemical reaction using the concept of bond energies. Now, we have a chemical equation on the screen right now that I just labeled, and we were asked to calculate the enthalpy change for this chemical reaction, and we were given the average bond energies for different types of bonds. So to start off this question, the first thing we need to know is that when it comes to bond energies, the enthalpy change delta H is simply equal to the energy of bonds broken, which represents the reactants, minus the energy of bonds formed, and this represents the products. So to solve this question, we simply need to find out the energy of the bonds that have been broken, which stands for the reactants on the left side of the equation, and then we also need to find out the energy of the bonds that have been formed, which stands for the product on the right side of the equation. So let's get into this question step by step. So for the energy used for the reactants, which is CH4 plus 2O2, let's get the total energy for the bonds that have been broken. So first of all, we have CH4. CH4 has this structure, C linked to C, or linked to H rather, linked to 4 atoms of hydrogen. From the average bond energies, we see that the C to H bond has an energy level of 412 kilojoules per mole. So that tells us that 4 CH bonds were broken in terms of this chemical reactants. So for CH4, we have 412 kilojoules per mole times 4, because CH4 represents 4 CH bonds that have been broken. So we have 412 times 4. That gives us 1,648 kilojoules per mole. That is for CH4. We have done that. So now we need to calculate for the second reactant, which is 2O2. So let's do that very quickly. O2, you can see it over here, has a bond, or a bond energy of 498 kilojoules per mole. Alright, so how many O2 bonds were broken? From the equation, we see that it has a coefficient of 2, which tells us that 2 O2 bonds were broken. So we have 2 times 498 kilojoules, which gives us 498 kilojoules times 2. It gives us 996 kilojoules per mole. So altogether, the energy, or the enthalpy for the reactants, will now be equal to 1,648 plus 996. 996 plus 1,648. That gives us 2,644 kilojoules per mole for the reactants. So now that we have the ones for the reactants, let's go ahead and get the ones for the products. So first things first, what are the products? The products are CO2 plus 2H2O. So let's get the bond energies for all the individual products. First of all, we have CO2. CO2 has this bond structure. We have C, which is linked to a couple of oxygen atoms. Now, from the bond energy rundown they have showed us that C to O bond has a bond energy of 805 kilojoules per mole. Now, how many C2O bonds were formed? We have one over here and we have two, which tells us that we need 2 times 805 kilojoules per mole in order to calculate the energy of this CO2 bond that has been formed. So we have 2 multiplied by 805. That tells us that we have 1610 kilojoules per mole for CO2. That's the energy of the bond formed. And then next up we have 2H2O. 2H2O has this structure, O linked to a couple of hydrogen atoms. All right, this is what H2O looks like. And from the bond energy rundown, we have been told that O to H bond has a bond energy of 463 kilojoules per mole. Now, how many of those bonds do we have? We have one, we have two. And from the chemical equations, we have 2 moles of water that have been formed. So that tells us that we need 2 times 2. Since there are 2 bonds of H2O and then there are 2 moles of that bond. So we need 2 times 2 multiplied by the bond energy, which is 463 kilojoules per mole. So altogether we have 4 times 463. That gives us 463 times 4. That gives us 1852 kilojoules per mole. So now finally, to get the energy or the bond energy of the products, it will now be equal to 1610 plus 1852. 1852 plus 1610 gives us 3462 kilojoules per mole. So at this point now, we can now get the enthalpy change for the reaction. And the enthalpy change for a reaction based on bond energies is equal to the energy of bonds broken minus the energy of bonds formed. This one stands for the reactants and this one stands for the products. So this is equal to the reactants. We've calculated the energy for the reactants, which is 2644 minus the product, which is 3462. 2644 minus 3462, that gives us 818 kilojoules or minus 818 kilojoules per mole. So the enthalpy change for this reaction is minus 818 kilojoules per mole. What this simply means is that it is an exothermic reaction, because when the change in enthalpy in a reaction is negative or minus, it means it is an exothermic reaction. An exothermic reaction is a reaction that gives off heat in the process of occurring. But if the enthalpy change is positive, let's say we had plus 818, it means it is endothermic. An endothermic reaction is simply a reaction that absorbs heat from the environment. I'm sure you saw how we calculated the enthalpy change for this reaction. If you enjoyed this video, please like, share, subscribe, and I'll see you in the next episode where I treat another question. Up until then, my name is David, and all I do here is to take the mystery out of chemistry so chemi can make history. Thank you very much.